Okay. Welcome to the Stanford Digital Economy Lab Lunch Seminar. I'm Christy Coe, and today's seminar speaker is Georgios Petropoulos. Georgios holds a bachelor's degree in physics, master's degrees in mathematical economics and econometrics, and a PhD degree in economics. Georgios' research focuses on the implications of digital technologies on innovation, competition policy, and labor markets. And he is currently studying the regulation of digital platforms and the relationship between big data and market competition. His research focuses on how the adoption of robots and information technologies affect labor markets and firms' market returns. Georgios is also a postdoctoral researcher at the MIT Initiative on the Digital Economy and a research fellow at Bruegel, an economics think tank based in Brussels. We welcome and encourage questions during the seminar. If you're in the Zoom audience, please submit your questions using the Q&A function in Zoom. For those of you who are here in person, we have mic runners that will come by. Just raise your hand and I will make sure that they come to you. We may have to repeat your question for the virtual audience as well. So Georgios, welcome to Stanford. Please tell us about platform competition and information sharing.
Thanks so much, Christy. It's great to be back and great to interact with all of you here. Thanks so much for this introduction and for the opportunity to present my research here. So I'm going to talk about a paper, joint work with Bertin Martens, Jeffrey Parker, and Marcel Van Alstyne. Jeff and Marcel are also digital fellows at the Digital Economy Lab here. And we are concerned about big platforms and how they contribute to the competitive process, what are key regulatory issues that they are related with their operation, and how state-of-art new regulations should be designed in order to make, to get as a society most out of how these platforms operate and how the value they generate redistributed in digital markets. And the starting observation has to do with the fact that these platforms have an enormous success and they have an enormous market capitalization as a result. It is now the case that big tech collectively, they have market capitalization that far exceeds previous corporate champions, like the ones come from the oil industry or the banking sector. And for that, of course, it's related with a business model, the new reality of digital markets, and some forces that can play an instrumental role for their growth and success. Platforms, by definition, are multi-sided firms connecting different sides. In the most simplistic setting, we can say that they connect supply and demand. We have important economies of scale. There are some important sunk costs for establishing the business, but then the cost of expanding the business is not so high. And we have the important role of data, which is in the central attention of this presentation. The fact that they use the data and the information this data convey in order to provide efficiencies in the market, and in this way increase the value generated by these markets. And they are assisted by the existence of network effects in the same side or cross-side, which basically expand the size of the networks we have in these markets. So it is, of course, this explains to some extent why we had this enormous growth and success of these firms, but at the same time, it generates some concerns. And the main concern is whether the value and the efficiency gains these platforms bring to the economy is distributed in a fair way. And there are more and more voices around the world which basically suggest that this is not the case. And therefore, we need to regulate big platforms in order to redistribute the value they create towards to their users, to consumers, business users, and sellers. The traditional approach, as we see in different jurisdictions towards this dimension, here is an indicative list of proposed regulations in the US. And as you can see, there are multiple. In Europe, we have a more coordinated approach that basically we have a more elaborated regulation that has already been approved, but it is one piece of regulation, the main one that we use here, the Digital Markets Act. And the point is to what extent we can use regulation, and especially antitrust regulation, to redistribute this value in digital ecosystem and have users benefit more by the participation in platform ecosystem. And to do that, probably, and this is a central theme in our paper, we should go beyond this antitrust proposals. We should go beyond the trust approach. And on the one side, we should recognize the immense value the big tech platforms bring because they centralize information. And by centralizing information, they can provide more efficiency services, more efficiently, for example, matching supply and demand, and that has value. But at the same time, decentralized markets create information asymmetries. The platform in the center of this ecosystem, the intermediary, has much more knowledge about the ecosystem itself than any other agent. And if we are talking about big tech, which collects enormous amounts of interaction data, interactions that the users have within the platform market, then it is also harder for competitors of these big tech firms to compete with them because they are missing valuable information that could be efficient and help them to improve the value proposition in order to enable more competition in the market. So this is a fact in the heart of our analysis is how we can make digital markets more efficient in order by distributing information and value in a more symmetric way. And I mean, we have, for example, we have many examples. So if we talk about online advertising, we have dominant firms like Facebook, Meta, and Google, which basically they monetize the information, the increased information they have to benefit from online advertising. We have the Amazon collection of data from interactions and transactions occur in the platform, which amount to a lot of a very high percentage of all transactions in specific given market segments like the ebook sales. So it's clear that the big tech platforms are well ahead than competitors in terms of data collection and analysis. And that creates very asymmetric structures in terms of information. And that can be good news, of course. Consider, for example, a platform A and a platform B. And platform A has access to a lot of more relevant data for its market operation. Then the data feedback loop comes into play. So they can improve, this platform can improve the intermediary services by offering better products and services to their users. But they also can use this data in order to better train its algorithms to become better. And this is a feedback loop that is repeated. So the distance between platform B and platform A can increase in this way. That is great news for platform A. That means that platform A can provide even more valuable services to consumers and to users in general. So where is the problem? And this is the first question we want to answer. So the problem is what I identify and classify as the data bottleneck market failure. So platforms like platform A with large data advantage, monopoly of their information that it is unique only to it and not to any of the competitors, can also take the advantage of monetizing this information in its relationship to its users. For example, it could be that I offer a higher fee to the business users join my platform from the fee I could offer if I had more symmetric information structure, we had more competition in the intermediary level, and therefore there would have been more, I could not extract such a high value because of this information monopoly power. And this is exactly the data bottleneck market failure, the ability to extract more ends by the platform ecosystem because I have access to unique information about the operation of this ecosystem. And this information ranges to a lot of sets. It could be personalized information about the users. It can be aggregated information about the market characteristics and what are the best possible ways for users to interact based on this aggregated picture. But the issue is how we can achieve a data value redistribution mechanism which does not destroy the value by platform A, but it provides a way to create. We can have a more symmetric information structures which enable users to grab more of this value that it is generated. One of the proposals that have been discussed intensively is, for example, breaking up this platform A. What would have been the problem in that case is that if we break a platform A to smaller platforms B, we move down at the scales of data value, so we destroy value. Ideally, what we want is not a breakup, but a solution which allows us to be at point A, but we have more symmetric information structures at point A, which will enable more competition, and through this more competitive pressure, we will have more value goes to the users of digital platforms, not stay to digital platforms themselves. And the way to achieve that is basically, instead of breakups, to consider efficient ways of data and information sharing from the big tech platform to a competitor. And in fact, this is something that the European legislation, which has been approved, has already trying to do that to some extent. If we focus on non-personal data, and towards the end of the presentation, I hope I will have the time to talk also about personal data, because there the challenges are much more important. The European Union's Digital Markets Act obliges Google to provide to any third-party undertaking providing online search engines, so basically to any competitor of Google in the online search market, with non-personal aggregated ranking, query, click, and view data. And this data should be provided at fair, reasonable, and non-discriminatory terms. So that could be a starting point. But then that generates a lot of questions, which also motivated our paper to move beyond the data bottleneck market failure and to try to solve it. The first question is, how should we interpret these fair, reasonable, and non-discriminatory access terms? What is about? And to be more specific, how much data should platforms, big tech platforms like Google share? And at what price? Should the price be regulated or not? And why only have this regulation in online search? What about online marketplaces that we have other big firms there? What about social media that we have other big tech firms there? So this is the questions we concern in this paper. And we develop a model which basically elaborates this data bottleneck market failure through a game theoretic analysis. And then we go to the question, how should we design such data sharing initiatives, such regulations? What should be the amount of data? What should be the price? And so on. I will give you just a very brief description of the model. I will try to avoid technical details for this talk. I would prefer to focus instead on the intuition of the formal model and what we find, and I hope that this will motivate some discussion. I will give you the model itself. So we have two platforms competing, a big and a smaller one. And the platform has as an objective to match consumers and sellers of goods and services. So we have two-sided market, two platforms competing at the intermediary level. The platforms are located in the edges of a linear city 0 and 1. And consumers and sellers are uniformly distributed across this line 0 and 1. And what is the meaning of this distribution on the consumer side? is that consumers have differentiated preferences. If at zero is LinkedIn and at one point is another smaller platform, let's say Snapchat, a consumer that values more, a user that values more this professional environment of LinkedIn, the big platform, will be located closer to zero, because my preference is more aligned of using the social media platform for interacting in a professional capacity with other colleagues and people all over the world that they are in my profession, maybe. If, on the other hand, I want to have more relaxed social interaction with friends, posting about, I don't know, my vacations or a party I attended, then I'm closer to the other kind of social media, the smaller platform, which is more around such kind of an environment. So where I'm located in the line between 0 and 1 as an individual consumer depends on my preferences and how I prefer to join one platform given the services of that platform towards the other. And let's go a little bit to the utilities and payoffs. And we are towards the end of the equations of this presentation. I'm not going to show a lot of equations. So platform J sets an entry price for each seller who wants to join the platform. In a social media platform, this seller can be an advertiser. In a commerce platform, this seller can be a seller that brings its own online shop within the Amazon marketplace. And the consumer utility has the following components. It is the value of interacting with other consumers in platform J times the number of consumers that join this platform, the value of interacting with sellers in that platform J per seller times the number of sellers that join that platform, minus the distance I have to cover in order to arrive to this platform. So platforms such as 0, 1, where I'm in between, depends on my preferences. If I value more the professional environment of LinkedIn or the more relaxed environment of another social platform. So the distance I will cover to go to the platform depends on the value I get, the number of other users in the same side or in the other side, the sellers, and the distance that I have to cover. And on the seller side, we have a similar representation of utility. We have basically, we promote the value sellers get from interacting with the consumers times the number of consumers that join the given platform minus the price they have to pay. And the payoff of the platform comes exactly from this price an advertiser and seller has to pay. So this is a flexible representation because we can see that if we are talking about the social media platform, it should be the same side interaction of consumers that will be important for the utility. If we are talking about the commerce, probably reading the reviews of products and services of other consumers will be helpful, but the primary value will come from interacting with sellers that they are located in this platform. So we try to have a more general representation of the platform here by covering, preferences that could be matched with a search engine, e-commerce platform, or social media platform, and so on. And where is the information coming from? So this is basically the preparation for presenting you the main results of the paper. So we have an amount Q that's collected by platform J, and this Q is related to these values consumers and sellers get. The higher information I get, the platform collects and analyzes, it allows it, given all the other parameters constant, to have a higher network value from that. So if I collect a lot of value, a lot of information, that allows me to improve my value propositions, and my platform becomes more popular for consumers and sellers to join because they can derive higher value from that. And the information asymmetry and the basic degree of differentiation between the two platforms is that the one platform is a big one that has a lot of information, and the other platform B is a small platform that has not so great information, which cannot use to provide comparable value in terms to the value that can be offered by platform A exactly because it has access to more information. And the information sharing, like the one the EU regulation wants to implement, is basically from platform A to platform B. I share amount Q, which is in between the two information collected by the two platforms, and that leads basically platform B to improve its value that offers to users, sellers, and consumers than before, and become more competitive. And the question is, what should be the price for that information sharing? So we consider a flexible program. So the price, it's a take it or leave it offer by platform A. So in the absence of regulation, it's the platform A that has all the bargaining power to set the price that it wants. And in principle, it can extract all the surplus, all the extra surplus platform B gets by getting this information. But we have also an important parameter alpha, which is the second important parameter of the information sharing mechanism. This is a policy parameter, is how much the regulation will allow the platform A to extract as information ready from platform B. If alpha equals 0, it is like you should share this amount Q, but you should not ask anything in return. So Q and A, alpha, are the two important parameters of the information sharing mechanism which we want to find, because so far in the European regulation, this is vague terms and they haven't been approximated. So what happens before information sharing? And in the paper, we analyze further cases. Let me focus on this one for this presentation. So given QB, the users, the consumers to the right of XB bar go to platform B only. The users, the consumers to the left of XA bar go to platform A. So basically, we have a monopoly of demand over this segment by platform A and monopoly of demand for this modest segment for platform B, and some consumers are excluded. That leads to data bottleneck market failure. Platform A finds optimal to charge the sellers an amount that it is equivalent to the value they can derive by joining platform A. So they extract all the surplus from sellers, and sellers have zero payoff. For simplicity, you assume that sellers are not differentiated, they don't have transportation cost, it's zero, and they can join, they can move freely between these two platforms. But the analysis survives, and this data bottleneck if we had also this additional modeling option. So the optimal price that platform A will set, it's basically I extract all the surplus from the sellers because I have access to large portion of demand. I'm the only platform that this demand can be accessed because I have the monopoly, so I charge high price. This is the data bottleneck market failure. Let's see now how this situation changes if we facilitate information sharing of amount Q. So what we have now is that the quality of platform B, the quality of service and the value its users derive has increased because now has access to QB plus Q. That means that the potential demand for platform B has increased as well. It has become more competitive in the market. And we have a new situation in equilibrium. We have, again, some sites that go either to one or the other platform only, that's single home. But we have the emergence of a great area of multi-homing, consumers that go to both platforms. And what does it mean? It means that the market power of platform A has decreased. Instead of setting now, it will never find optimal to find such a high price as before, because if it sets high price to sellers, the seller says, what? Forget it. I'm going to platform B. I can interact with a lot of consumers there. I don't need you anymore. You are not anymore the gatekeeper. So in equilibrium now, the price that the platform A sets is much smaller than before information sharing. Sellers have positive payoff out of that. Consumers are also benefited. there are no any consumers excluded. And on the top of that, in the multi-homing area, consumers can get a higher value because they visit both platforms. So multi-homing area basically are the consumers that both value to interact with other professionals, but they also want to be in the less formal and professional platform and interact with friends. So because of information sharing and the ability of Platform B to improve its value proposition through the information it receives, we have more competition, more symmetric information structure. Information symmetric structures lead to more competition. More competition leads to the elimination of this data bottleneck market failure, and we have basically redistribution of value because of increased competition from Platform A to all the other actors of the ecosystems. Platform B it will be better off. It improved its quality as well. Consumers and sellers are better off because of the increased competition. They can have better terms of service in the market. And the question is then, do we need regulation for that? Or it's something that Platform A should be something that will be willing to do alone. So in the paper, we characterize all the space of all the different cases of the parameters. But the basic point is, obviously, for Platform A, we have two effects of information sharing. The first one is the direct market losses, because now Platform B becomes more competitive. The second is the information payment. I will share some data, but I will get some payment out of that. And this is the positive term. It appears that in cases that we have initially high information asymmetry, it is always the first effect that dominates. And therefore, social incentives, which in this case are modeled in line of what the regulator wants to do. The regulator wants to redistribute value from the big tech to other actors of the ecosystem. So basically, it cares mostly about consumer welfare and business user payoff. Although in this case, total welfare considerations would have led to a similar conclusion. It is that the social incentives are greater than the private ones for information sharing, and significant one. So indeed, there is a scope for considering a regulation for a mandatory data policy. Now, how this policy can be defined? So we go to the second part of the model, where we discuss what should be the exact terms of information sharing mechanisms, from the point of view of the social planner. So far, we have been working on the third model by considering two platforms choose pricing given the information structure. Now, what we do is we consider also the data investment decisions by Platform A and Platform B, because the real risk here is I oblige Platform A to share too much information, and therefore Platform A will not have any incentives to collect information in the first place. I collect information and analyze information. I keep high my value, network value for my users. But if I'm asked to share all this information with competitor, what are my incentives to do that anymore? And we want to take this into the analysis. So what we have is a regulator that announces and implements a mandated sharing scheme, which has two characteristics: the amount of data that Platform A should share to Platform B, and the price, which goes to parameter alpha, as we discussed earlier. And then Platform A and Platform B, given these mechanisms, they decide about their data investments and basically how much QAI and QBI they will select in equilibrium. And then we have the pricing decisions. The pricing decisions, it's exactly the previous story I presented. It was the last step. But so what is the main result of this paper then? Is what is the socially optimal data policy mechanism? What is the optimal Q and what is the optimal alpha? And we find, surprisingly, that alpha should be 0. The big tech platform should not be paid for the data that it shares. And of course, that is surprising because you could expect exactly the opposite. If I don't pay the big tech, so basically the big tech will not have any incentive to share data. But the issue is exactly the opposite. It's by shutting down the one source of revenue, which is through the payment for information sharing for the big tech platform, the big tech platform is incentivized to invest more on the data investment, because the only way to make some profit, to be profitable in the market, is through the data investment it made, through the product market itself, not through the payment of the information that it has to share. And the second element, Q, depends on the second order effects to data. And I will illustrate that in the following slide. So basically what we want, the issue here is that indeed a mechanism that obliges platform A to share data will have adverse effect in data investment they make. And the more Q I ask him to share, the lower will be the QA, which means that XI bar now moves also to the left. It declines the value of platform A and how attractive it is to consumers. So knowing that, I need to balance two effects. This adverse effect of Q to the platform A, by keeping the price alpha to 0, I mitigate this effect. And basically, what I want to have is a situation where this distance, XB bar, XI bar, is maximized. We reach a level in which platform B has been much more valuable, has attracted a lot of consumers, but platform B, because of this adverse effect of information Q, hasn't lost a lot of the value. And that is basically the optimal mechanism, which depends on the second order effects. So when we will have significant data sharing, and that depends on second order effects. Imagine that we have this S-based curve for illustration. Now, any value Q that is shared from platform A to platform B will increase the value of platform B. It will move the point along the curve to the right, and it will decrease a little bit the value of platform A, exactly because we have these adverse effects on data investment. If you oblige me to share information and data, I will not invest so much as before. But what is the trick here? The value of platform A is already in the diminishing part of the curve. Even if it is lose some value, this will not be so costly because in absolute terms, the value decrease will be very small. If I stop investing so much in data because I'm the diminishing returns part of the curve, the value will not be so much affected. It will decline, but by not so much. On the other hand, the platform B that it is far behind can get much more benefits in terms of value because of this data sharing. It is in the steeper part of the curve, and the value increases a lot. So it is this relevant increase of value B and decrease of value A that determines how much information I should share at a 0 price. So conclusion, if data exhibits diminishing returns to scale, as some people argue and have shown, for example, Hal Varian has a paper exactly pointing out that data exhibits diminishing returns to scale. Or if we have an S-based curve like here, we expect that the optimal socially amount of information sharing should be substantial, because you will have substantial gains here. Platform B will increase a lot its value, and platform A will only decrease a little bit its value. Still, we have more competition. Still, the data bottleneck market failure will be removed, and will have more benefits for users and consumers. If, on the other hand, and for specific services, data exhibits increasing returns to scale, then probably data sharing to large scale is not a good idea, because then probably MA, the value of platform A, will go down a lot, and we don't want this because it will destroy value. So that is the model itself, and certainly does not apply as a regulation to non-personal data. It could be extended for personal data as well. And in fact, we have a different part of the DMA, the European regulation, for personal data, which basically authorizes users, either business users or individuals, consumers, to have more control over their data and be able to authorize their data from big tech platforms. And big tech platforms basically are Alphabet, Amazon, Apple, ByteDance, TikTok, Meta, and Microsoft. Those are the big platforms. The users should have the right to authorize sharing of their data, porting their data from these big platforms to others. And we are talking now also about personal data in the case of individuals. What is the problem? The problem is that, yes, in principle, we want to give more control to people over their data in digital platforms. But in some cases, like in social media, interactions involve different individuals. This means I interact with someone else, and it's very hard to assign property rights in order to be able to basically divide what is mine and what is your data in this interaction. It's code-generated data set. And that makes it extremely hard for this regulation to be effective. Let me give you the following illustration. David and Gabriel are two people working actively behind the scenes, helping with the organization of this seminar. So David, the other day, said to Gabriel, look, I love the ice cream place at the Stanford Union Square. And Gabriel responded, me too. What is the fundamental issue here? The context of this interaction, which also reveals Gabriel's preferences, that he likes the ice cream from that place, is given by David. Gabriel does not have any right to touch this data and authorize this data to be shared because it is code-generated and the context is destroyed if he does it. So Gabriel can share the me too response, but this is without context. We don't know what we are talking about exactly because the context is provided by a post by David, which is personal information of David. And that is exactly the problem. And we have come with some ideas how to solve this problem in the case of personal data. And we have another publication already out, which is a short version of a follow-up paper of what currently we are working. And essentially, the point is that we need a new mechanism for sharing personal data, or better, a new mechanism for providing more control, more power of individuals at this digital age to access and use their data in digital platforms. And the mechanism in a social media context would be that we have an intermediate space, we have a personal data space by Gabriel, where basically when the platform, the social media platform, collects this information, there is at the same time a copy of this interaction point that is saved on this personal data space, which is transformed in a way that David's personal information is not revealed. In this case, probably would be Gabriel loves ice cream place at Stanford's Union Square. No data, we keep Gabriel's preferences, but David's preferences are not revealed. So we need an intermediate step, and we need to work on software technologies that in the age of large language models are more capable to move to this direction in assigning for each individual a personal data space, which will allow data to be stored in a way that personal information of other individuals is not revealed. And then Gabriel can use the regulation to share his data. I will stop here. Thank you very much.
We're going to take questions from the group in a minute, but we're going to invite Seth Benzel, assistant professor from Chapman University and also our digital fellow here at the Stanford Digital Economy Lab, to offer some initial feedback and thoughts on this paper.
Well, Christy, thank you so much for that introduction, and thanks to Georgios for inviting me to give some kind of kickoff thoughts on his timely and sure to be influential paper. So not so much a complete discussion right now, but just some ideas for you guys to contemplate in the discussion. Two things that I really like about this paper. Firstly, I like how it has a very clear question about is data sharing, can it be socially optimal? Does the socially optimal level of data sharing happen automatically? And gives a clear answer to that. So information sharing is good in this model because it helps a follower make a better product, but it also helps the follower compete with the leader, right? So the leader is going to be okay with selling data to the follower as if it's just making his product better in the trapped market, but the leader is going to kind of undersell data if it's going to let the follower compete with the leader. So therefore, sharing data, enforcing a sharing of data can increase social welfare, especially if aggregate data quantity is fixed. But there's a kind of a trade-off here, which is if you force the leader to share too much data, they're going to reduce their data collection, and then that's going to have a drag on productivity. Kind of the second thing I like about this paper is the focus on the role of nonlinear returns to data. I think this is we're already struggling, a lot of researchers, with just the kind of the first level question of what's the average value of a data set. But if you really want to think about bargaining power and marginal incentives, much more important than the average value of the data is the marginal value of the data. And I've run into this not only in the domain that Georgios is talking about, where we're talking about competition between platforms, but if you want to write down a model in which individuals are bargaining against the platform, understanding whether there's marginally increasing or decreasing returns to data is going to be absolutely critical. And so I'm glad for one more paper pushing us in that direction. Intuitively, in this model, the nonlinearity matters because it's costless for me to sell productivity to a firm, just marketing to their trapped market. I can give them as much data as I like. If they're really sucky, their data quality is bad, they're not even competing with me. And then the second way it comes in is that it's worse to disincentivize data collection when there's increasing returns. For these curves, if there was a firm that was kind of on this upward sloping part of the S curve, the last thing you would want to do is give them any disincentive to invest in data more. So I also have kind of two you might think of them as sort of moving forward questions, directions for further research, or just kind of questions that if you answered would help me understand your findings better. So the first question is, to what extent is this sort of broad finding unique to the platform ecosystem? In other words, kind of more generally, if you had told me, hey, should the government force a leading firm to share its technology with a following firm, I would in general say that there's a trade-off. Well, on the one hand, if you share the technology with the following firm is going to be more productive and better, but you're going to discourage innovation and maybe even entry of the leading firm. And so one question I have for Georgios is, to what extent is this finding that, you wanted this intermediate amount of sharing unique to this platform domain, or what does the network effects part add to it separately than what I could tell in a story without network effects? The second question is around the benefits of coordinating on a single dominant platform. So this is definitely a model in which people, certainly consumers, are way better off if there's multi-homing and there's like a large range of people who could do one or the other. That's going to lower the prices. The platform users are going to be really happy when they have the opportunity to multi-home. But I can definitely write down a model in which everyone coordinating on driving either on the left-hand side of the street or everyone driving on the right-hand side of the street is a much better outcome than, we multi-home and we have different streets where we drive on different sides. In such a situation where it would be good if we all coordinated on the best platform or the best rule, a difference in quality between the best option and the second best option is actually helpful. It helps us coordinate on the best option, and then everybody's coordinating, everybody's cooperating. That's the social welfare best. Why doesn't that happen in this model? My sense is that that isn't the case here, is because multi-homing is cheap, right? There's no kind of additional cost for having to go onto a second home. And also because of this horizontal differentiation. We actually want multiple platforms because we want some people to be closer to platform A and closer to platform B. So my second challenge to Georgios would be to think through, what are the assumptions of this model that makes a less coordinated outcome, the optimal outcome, versus everyone coordinating on the most efficient, best platform. And maybe something around that direction is to think about what happens to the model when transport costs equal to zero, right? So we know Meta is kind of getting at what you're saying when you're saying, okay, I want to be on the LinkedIn platform and talk about jobs, and I want to be on the Instagram platform and look at photos of vacations. Well, there's some sense in which Meta is trying to make a platform for everything, right? And if they can have the data across all these different platforms, and they're kind of locating their platform everywhere on the street, well, that's going to eliminate the sort of horizontal differentiation, hoteling part of the model. Okay, otherwise, really, really interesting paper. Again, timely and sure to be influential. And thank you, Georgios, for inviting me to give some comments.
Thank you very much, Seth.
Eric, do you want to jump in?
Yeah, actually, if I just have some quick comments. I'm sorry I can't be with you all. I'm in Barcelona today, but welcome back to the lab, Georgios. That was a great talk on a really important topic, and it was good to hear your insights. And by the way, thanks also, Seth. I like this model of having a discussant for the paper. I think we may be doing that more based on how well you did. Appreciate that. Georgios, my question kind of builds a little bit on Seth's second point about the increasing returns, or the different returns to scale to information, which I think is a really interesting direction to go, especially as you start thinking about how this applies to machine learning and artificial intelligence. A lot of those models, of course, especially the large language models, but most of them are driven by data availability, and there's a lot of discussion about smaller organizations or academia not having access to some of the same big data sets that the Meta, Google, or OpenAI do. But also the other direction, that those companies may be getting, sharing could give them access to information that we all have. So my question is really building on Seth's. What are your thoughts about what that might mean for concentration or competition? And would data sharing, what circumstances would data sharing lead to more concentration in a small number of companies or a single monopolist? And what situations would it lead to more competition? And which ones do you think are empirically going to be more relevant when it comes especially to machine learning systems?
Thanks, Eric, for the question, and also to Seth for the discussion. Let me answer the questions in turn. So, Seth, thanks so much for, I couldn't put it better, and the framework of the model, but this is exactly what we want to have. It's to establish a framework which also guide new empirical research questions. And as you said, the second order effects of data could be really important for the future understanding the competitive implications of sharing of data. So why this paper is unique to platform ecosystem? I would say that starts with illustration of the data bottleneck market failure. So the data bottleneck market failure requires multi-sided markets and requires also the data to play some role for the network value I derive. So I would say that it is more relevant to firms that they are organized as platforms, and to firms that are organized as platforms and they have this multi-sided dimension where the data bottleneck can arise, which is basically high information asymmetry between few big tech firms and the competitor, let's say, in that particular sector. Certainly, we could go beyond the motive, which also to evaluate the European regulation. The European regulation applies only to a handful of big tech platforms. So that was more or less the motivation, but certainly could move, expand a little bit the framework and the examples, as you suggest, to other firms. But we need the multi-sided markets for having this data bottleneck arising. On your second question, and that also is related to the point by Eric. The question is, how do you define the best? Having coordination is the best for whom? Because exactly the data bottleneck illustrates that the incentives, the private incentives and the social ones may not be in the same line. and especially when we are talking about an established market service, not so much a new one like machine learning and AI, but an established market service, core service like search engine, like e-commerce function, and so on, where clearly there can be equilibria in which platforms can decide optimally for their private objectives instead of the social ones. And I guess the point of coordination is really important. So in order to arrive there, the key question to understand is at what cases the value generated from coordination benefits a lot just one actor of the ecosystem, the platform that it is in the central space and an intermediary, or these benefits from this coordination are shared with other actors of the ecosystems as well. And that also brings to the point about concentration versus competition that Eric made. So I think if we keep systems open, if we keep the freedom of users of these platforms to have more rights over their data, to be able to move freely from one platform to the other, not to have technical difficulties, not to have some business model difficulties for doing that, then indeed we can arrive to an equilibrium where this coordination, especially with respect to the huge benefits that AI and ML can have, can be realized and can have also important, not only private, but also social benefits out of that. So I think the matter is how to organize the platform markets and how open they are in order to move to this direction of more competition, more freedom of users, and more competition can lead also to more innovation, because I can increase my investments in order to be more effective in competing with competitors. Otherwise, if we keep more closed system and information structures, if they are symmetric, we are in a more closed system. If we stay there, then the benefits of data and information may be limited to only a few actors. And this is what we want to avoid. This is not only important for competition, right? I was checking outside, there is an advertisement that tomorrow is the Democracy Day and there are some events in the campus. So it's important for democracy to have more control over our data and be able to move around freely in order to achieve more efficient and more valuable digital markets and more inclusive as well.
Do we have any questions in the room, or we'll go online?
Hi, Georgios, this is fantastic. Thank you so much for sharing your insights with us. I completely understand your point about information sharing and the value of that and distributing value. I want to push a bit more for me to benefit from your work. How would you see this playing out if the key actors that hold the data are not in the private sector, but happen to be in the public sector? For example, in some of the European countries that I have lived in, public data belongs with the government very often. So would you like to have a similar model of information sharing in those cases? Or is that something where you would consider different types of models playing out?
Thank you. Do we collect questions or I go one by one? Okay, let's, thanks for this question. So it is true that if we are talking about public sector initiatives and data, that goes a little bit beyond the main point in the paper, which is about competition. But it has to do with the efficiency gains I can bring to society. So I don't believe that the competitive arguments there are so fit, just to be clear about that. But still, let's say the model setting where information sharing can provide some value to other actors of the economy is still there. So if we miss the competition, but we have this benefit, we still need to share data, because in this way, we will be able to have a more informed agency in the economy, which can use this data for new ideas and develop new, probably, products and services that are available to society. and also to some extent improve the entrepreneurship, especially in Europe. We need that. So the only thing that we should be careful, and there is where we need a new mechanism in place, is whether sharing this information will have some privacy or business transaction, secret business transaction costs. And this is something we should avoid. So we move indeed beyond the competition argument here, and there we should carefully balance the value of this data sharing with potential costs and risks which depend on the specific case. If we're talking about healthcare, for example, this data is very sensitive. We should aggregate it in a sufficiently high dimension to ensure that the de-anonymization will not be a risk. And of course, you need to think the context of the specific social benefits it can bring of sharing this data. We should do that only in that direction. But there are examples and applications where making more informative, better flow of information would be really helpful for the social point of view, from a social point of view.
Great. Jose Ramon?
I think, thank you so much for sharing your work. I think that high quality research is very well needed in this space. And thank you so much for sharing this piece. The framework that you present seems to me very similar to telecommunications networks. And in some countries, certain companies are forced to share their network with the smaller companies. And we know that in those settings, small companies not only have access to the network, but sometimes they do not have priority in that network. So you're kind of you're kind of playing on the extensive side of things, but also there's some on the intensive margin. So can you say something about that? Because these big companies may share low quality data or not so good data that smaller companies can use. And also related to that, since big companies like company A will not be given any payment for the data, they might be pushed to use the data they have to do more price discrimination rather than personalization, which might be better for the consumer. So what can you say?
Yeah, thanks. Those are excellent points, and certainly reveal that this is a topic where we need to think a lot, develop also additional dimensions like the one you propose. I love your comment about price discrimination. So I would say that the key aspect of the data is, especially when we are talking about personal data, is that it is the user that can be in charge of the sharing. It is the user's data that should be shared. And according to the regulation, by the way, the data portability right, which is the personal data sharing ISO for Europe, applies also for California. Not sure if you have heard it, because it has not been implemented in practice. But as a right exists, we have a right to go to platforms and share the data with another authority, but exactly, we don't have the mechanisms to do that. So I believe that is the key to avoid some of the risks we have seen in the telecommunication. And I love your analogy with telecommunications because it is very relevant here. So assuring that users are in charge of their data platform is one big step towards the dimension that we reduce the amount of strategies that platforms can implement in order to somehow escape from the competitive pressure they will get from this data sharing. And this is just a matter of designing an effective mechanism for this to happen, because the regulator needs an effective mechanism for that. We don't have any mechanism on that today. So this is a great topic. If the first topic is understanding the second order effects of data on value, the second great topic is exactly that, to be able to come up with a software mechanism empowered by AI, which will be able to give more control to people over their data.
And that wraps up our talk. Thank you so much, Georgios. Please do join us next time, November 20th, when our speaker will be John Fernald, who'll be talking about productivity during and after the pandemic. If we didn't get to your questions, we're sorry. We do our best every time, but let's all thank our speaker one last time. Thank you.
I mean, if there are some unanswered questions, I will be today, tomorrow here, so we can, please feel free to reach out. Happy to talk further with that with you.